Hello everyone, this is question number 18 of next 2025 exam. The question says a tube of length 0.5 meter open at both ends has a small hole in between in the middle. Air is blown through this hole. If the speed of sound is 330 meter per second, the first three harmonics in hertz are. That means, let's say I have a pipe or a tube like this. Okay, in between, in the middle of this I have a hole. Now when I blow air from this hole, the sound will produce, or the frequency or the sound will produce only when it reaches from one end to the other end, either this end or either this end. Okay, let's say all the sound goes from this to this end. Just assuming this case, it will also go through the left side as well, but for assuming through the right side only, since this is an open, both sides are open here. So this type of waveform will be formed. The wave will be like this. It has node antinodes at the edges and a node in middle. Since it is open at both sides, that's why. Now, little theory behind it. If I have a wave like this, or if I have a resonance wave like this, resonance tube, in resonance tube, the waves formed are like this. And if I have a antinode at an end and a node in the middle and antinode at the other ends, the distance between any two antinode or node is lambda by 4, and a distance between an antinode or a node and a node is lambda by 2. Okay, so it is applicable for this as well as this. Okay, let's say I have a antinode in the middle and two nodes at the ends. Similar is applicable for this as well. This complete distance is lambda by 2, and the distance from node to antinode, this distance is lambda by 4. Okay, so now focusing on the question again. Now this question says that we have to find the first three harmonics in hertz. Okay, so now this complete distance is L. Okay, this distance is L by 2. And how many nodes or antinodes are formed? A node for the first harmonic. Okay, for the first harmonic this will not be the case. For the first harmonic this will be the case. Since these are ends, so nodes cannot formed at open ends, so there will be an antinode formed. Okay, and two antinodes at two ends can be formed like this. So this is possible for first harmonics. So for first harmonics this is the case, and as I said, between an antinode and a node the distance is lambda by 4. So what is this total distance? The total distance is equal to L by 2, and it is equal to lambda by 4 into 2. That is equal to 2 lambda by 4. So L by 2 is equal to, or we can say that L is equal to lambda from this equation. Now frequency. What is frequency? Frequency is V upon wavelength lambda. Speed of light divided by wavelength lambda, it is frequency. Now from here we have calculated lambda is equal to L. So by putting this in this equation, we will get the value of frequency is equal to V by L, that is this. Okay, so now we know the length is 0.5 meters and frequency is 330. 330 divided by 0.5, which is nothing but 330 into 2. that is 660 hertz. So for the first or the fundamental frequency is 660 hertz. Now it says we have to calculate the first three harmonics. So first harmonic is this. Now for the second harmonic, what will be the case? For the second harmonic, this wave will be now slightly different. There will be two notes formed. It will be something like this. This will be the wave. Okay. Now here we have two nodes formed. One node is this, second node is this, and we have three antinodes. This is one antinode, this is one antinode, and one antinode between these two nodes. So now the total wavelength is equal to, this is lambda by 4, and we have how many such? One lambda by 4, another between these two, another between these two, and another between these two. That is lambda by 4 into 4 times, that is lambda. This complete wavelength is now what? This complete wavelength is lambda. Or I can write it like this as well, lambda by 4, this is lambda by 4, or I can write this as this complete is lambda by 2, and this complete is lambda by 2, giving us the total wavelength as lambda. So now by this we get new length. The length of the tube is it remains the same, but for the wavelength is changed, that is lambda. Okay, from this I got the value of lambda as L by 2. Now for the second frequency, second harmonics, frequency is equal to, this is f1. For f2 it is equal to v by L into 2, that is equal to 660 into 2, that is something around 1320 hertz. Similarly, if I do for the third harmonic, then there will be three notes formed. In that case, this will be equal to what? This will be equal to lambda uh, by 2, 3 lambda by 2. It will be equal to 3 lambda by 2. So hence F3 will be equal to V by L into 3. On solving this, we will get 660 into 3, that is 1980 hertz. So by this, the correct option is option A. Hope you understand the solution. Thank you very much.